All right, so we're going to talk about electromagnetic induction. And basically, electromagnetic induction is something that happens when moving magnets get near a coil of wire or a current flowing through a wire creates a magnetic field. So both of these things can be considered the same idea. Magnetism can produce electricity. So if you move a magnet in and out of a coil of wire, it's going to produce electricity in the wire. If you move that coil of wire back and forth around a magnet, it's going to do the same thing. So either way, when you're thinking about these, think one is moving relative to the other. And that induced voltage in the wire can be increased by moving the magnet faster or increasing the number of loops. Just to get into some detail so we can talk about what's going on with the magnetic field. As that magnet approaches the ring of wire, there's a magnetic field created by that current flowing through the wire, and that new created magnetic field is going to oppose changes in the strength of the total magnetic field. So as the magnet gets closer, that north side of the magnet gets closer to the wire, the new magnetic field is going to work against it. If you're removing the north from the wire, the magnetic field is going to try to pull it back in. It doesn't like change. It's going to resist it. And the idea that you can move a magnet and get electricity doesn't mean that the electricity was like, oh, free electricity, yay. No, it takes work to move a magnet. You can imagine that it's either going to be moved by a hand crank or a motor crank, or you moving it somehow, but somewhere there's some energy being put into the system in order to create that electric current. And there's a way to figure out what direction current is moving, and it's called the right-hand rule. There's a couple different right-hand rules, but this is a very simple version. Your thumb is going to point in the direction of the motion of the North Pole. And so in the picture we've drawn, it's downward, down the page. And then your hand, if you look where you kind of make a fist, your fingers are going to curl in the direction that the current would flow for that magnetic field. But remember, we've got that opposing magnetic field, so you have to flip it. So the current is flowing opposite the curl of your finger. So when I started this, I talked about how a current moving in a wire could create a magnetic field. And very simply, that greater the current is, the greater the magnetic field is going to be. And kind of like the earlier illustration, there is a direction associated with it. If you know what direction the current in the wire is going, then you put your right thumb in that direction, and then your fingers are going to curl in the direction of the magnetic field around the wire. And if we go back and look at that original example one more time, you see that north end of the magnet moving towards the ring, and it's going to create a current in the wire. And if you notice that current in the wire is drawn so it's kind of going counterclockwise, you'll see that magnetic field around the wire created by that current is going to be in the opposite direction inside that loop. So that kind of brings it back. That this does take a little practice to kind of get used to this idea, but it is very handy for working with the idea of electromagnetism. And electromagnetic induction is used for a lot of different things: motors, generators, transformers, all sorts of devices use the idea that we're transferring energy from one type of energy, either mechanical energy to electric energy or electric to mechanical, or we're changing the voltage or current of the electric energy. And all of them work in a similar fashion. They depend on that interaction between the magnetic field and the created currents and created magnet fields from moving currents. So here's a real simple example just to kind of run through. They're all formatted differently, but you start off with a battery and you create a little circuit, and that circuit is wrapped around a metal core that can be magnetic material, an iron core. And so once that current flows in that first circuit, it's going to create a magnetic field in that iron core. Now that there's a magnetic field in the iron core moving around, that magnetic field in the iron core is going to create a current in the second circuit. And so that's how you get from one to the other. Alrighty, bye-bye.